Hello and welcome everyone. So this is the sixth video in the prime time series from the book Ganita Prakash Class 6th CBSE. So let's get started. First we'll check out the divisibility tests of different numbers. In the last video we saw that divisibility can be checked using prime factorization. That is a long method. Just by checking the last digit or last few digits, we can check whether a number is divisible by a certain numbers. So let us see the divisibility tests. Numbers that are divisible by 10 are those that end with a 0. So if at least one 0 is there, then the number is divisible by 10. Next, numbers that are divisible by 5 are those that end with either a 0 or a 5. So if the last digit is either 0 or 5, then the number is divisible by 5. Numbers that are divisible by 2 are those that end with 0, 2, 4, 6 or 8. So if the number has any of these 5 digits, it is divisible by 2. And if it has 1, 3, 5, 7, 9, then it is not divisible by 2. They are odd numbers. If the number is formed by the last two digits is divisible by 4, then the original number is divisible by 4. So we'll see why it is in the next few slides. We will come to know why this happens. Similarly for 8, if the number formed by the last 3 digits is divisible by 8, then the original number is divisible by 8. Let's see why if a number formed by the last 2 digits is divisible by 4, then the original number is also divisible by 4. Why this happens? So if you take any 5-digit number, it can be 7-digit number also. We are taking as an example. So let's take this 34,564. We separate it out into 34,500s plus 64. We take the tens and units digits separately. What we see is that this number, this is basically 345 into 100. And this is divisible by 4. 345 into 100. Why? Because 100 is basically 4 times 25. So this is a very good important fact. You can memorize that 100 is 4 times 25. You will later need it in many other calculation like percentage, conversion of percentage. So 100 is 4 into 25. And you can think it as 100 is 10 square. So 10 is 2 into 5. So 2 into 5, 2 into 5, it is repeating 2 times. And 2 into, if you separate out the 2's, we get 4, and separate out the 5, we get 25. So 4 into 25. So once these two parts, one part is divisible by 4, then the whole number will be divisible by 4 only if the tens and number formed by the tens and units digit is also divisible by 4. So we only need to look at the last 2 digits. So this is the explanation of why we need to look at the last 2 digits only. Similarly, if you see that 8, we have to check the last 3 digits. You might be guessing why it happens. So you take any 5-digit number, then separate it out like before. But now instead of 2 zeros, we take 3 zeros. So 34,000 plus 664. Now 34,000 is divisible by 8 because 34,000 is 34 into 1000 and 1000 is 8 into 125. This is also another important fact. You can remember that 1000 is 8 into 125. Later you will need it in fractions, conversion of fractions to decimals. So just memorize this fact and you can easily memorize it that 1000 is basically 10 cube. So there is 3 2's and 3 5's. So 2 cube and 5 cube, we can separate it out. 2 cube is 8 and 5 cube is 125. So that's why we need to look at only the last 3 digits, because anyway the number formed by these 3 zeros is always divisible by 8. So we need to check the last 3 digits. So this is the explanation for why we need to just check for last 3 digits if you want to check divisibility by 8. So now let's do the figure it outs from the chapter. Question 1. 2024 is a leap year as February has 29 days. Leap years occur in years that are multiples of 4, except for those years that are evenly divisible by 100 but not 400. So year 2000 is a leap year because it is divisible by 100 and also divisible by 400. But the year 2100 is not divisible by 400. So it is not a leap year. So let's see the part A. From the year you were born till now, which years were leap years? Suppose you are born in the year 2014 and this year is 2025. Then it is easy to see the leap years because it's a very few years are there in between. So 2016 is a leap year because 2016 is divisible by 4. 2020 and 2024 are leap years. All these 3 years are leap years. But if you have to do the part B of this thing, you need little more mathematics. So let's, from the year 2024 till 2029, how many leap years are there? First year leap year greater than equal to 2024 is because 2024 is exactly divisible by 4. This is also a leap year. So the first leap year is 2024. It's greater than equal to, we said. So 2024 is a leap year. Then what is the last leap year less than equal to 2099? If we divide 2099 by 4, we see that it's not exactly divisible by 4. So before 2099, which year is exactly divisible by 4? That is 2096. So 2096 is the last leap year in this range. So the number of leap years, you have to divide the difference of these 2 years by 4 and add 1. This is important. I will discuss why we have to add 1. So this is difference is 72. 72 divided by 4 plus 1. That is 18 plus 1 is equal to, answer is 19 leap years. So let us see why we have to add 1. Why we have to add this 1? We have to divide by 4 and then why are we adding 1? So suppose we have to find the number of leap years between 2024 and 2028. What we find is that the difference is 4. But what did we do? We excluded 2024 from this. So we have to add the excluded year. So actually we know that between 2024 to 2028 there are 2 leap years because 2024 is also a leap year, 2028 is also a leap year. But the difference 4, when we divide it by 4, we get 1. But actually we see that there are 2. Why? Because we excluded this 2024 from this difference. When we are finding the difference, we exclude this number basically. That's how we get the number 4. But actually if you see the number of years between 2024 to 28, there are 5. 24, 25, 26, 27, 28. There are 5 years, but we get the answer as 4. So that is why we have to add 1 for the excluded year. This kind of, whenever we have to find the number of days between 2 dates, then also we have to find the difference and then add 1. So why we are adding? Because when we are finding the difference, we are excluding the last one. So again, we will come back to the problem. So we saw that the first leap year is 2024, last leap year is 2096. So the number of leap years is that we have to divide the difference by 4, then add 1 to it. So the answer is 19. And all these years are the leap years. But the year 2100 will not be a leap year by this definition because it is divisible by 100 but not by 400. 421 is not divisible by 4. So the year 2100 will not be a leap year. Now next problem is find the largest and smallest 4-digit numbers that are divisible by 4 and are palindromes. So what are palindromes? Palindromes are numbers that read same from the left as well as from the right. If you read this number 1221 and if from this side also if you read it, it will be 1221. It's the same number basically. So it's basically if you reverse it, if you reverse the digits, the number remains the same. These are all palindromes. So all the repeated digits are also palindromes because they anyway don't change, right? Because all the digits are same. So it's a 4-digit number, so it will be of the form ABBA, whatever be the digits. So for largest, let us try to find the palindromes. Largest possible A. What can be the largest possible A? Because it's a divisible by 4, it can be 8. So we have to fix A at 8 because then the number will start at 8. Otherwise, it won't be the largest, right? So largest possible A is 8. So what B can we have so that it will also be largest? Because B cannot be 9. 9, 8 is not divisible by 4. So B also has to be 8. So largest BA is 8, 8. Then what is AB? AB is also 8, 8. So the largest possible palindrome divisible by 4 is 8, 8, 8, 8. Let's see the same thing for the smallest one. Smallest possible A is 2. It cannot be 0 because then it won't be a 4-digit number. Because if A is 0, this A also has to be 0. So the smallest possible A can be 2 because otherwise it won't be divisible by 4. If it is 1, then it won't be divisible by 4, right? So it is smallest possible A is 2. Then what is the smallest possible B? B is 1 because 1 BA is 12, then AB is 21. So the number is 2112 because palindrome it has, if we reverse it, then also it should read the same. So the largest number possible is 8888 and smallest one is 2112. Both these are palindromes, both are divisible by 4. So that is it. So let's move on to the next one. Explore and find out if each statement is always true, sometimes true, never or never true. You can give examples to support your reasoning. Sum of two even numbers gives a multiple of 4. What do you think? It is sometimes true. Sum of two odd numbers gives a multiple of 4. This is also sometimes true. Let us see the examples to illustrate. So 12 plus 14 is 26. It is not divisible by 4. 14 plus 18 is 32. Both are even numbers. So sometimes it is giving a multiple of 4. Sometimes we are getting a number which is not a multiple of, we are getting a number of which is multiple of 4. Sorry, I am showing the opposite one. 26 is not a multiple of 4. So sometimes we are getting a number which is not a multiple of 4. 32 is a multiple of 4. So sometimes we are getting a multiple of 4. So if we add two even numbers, sometimes we get, sometimes we not get. So it is sometimes true. Similarly, when we add two odd numbers, 11 plus 13, we get 24, which is a multiple of 4. 17 plus 21 is equal to 38, which is not a multiple of 4. So this is also sometimes true. Find the remainders obtained when each of the following numbers are divided by 10, 5, 2. So we know that a remainder is always less than the number starting from 0. So if we divide by 2, we can get, there are two possibilities of remainder, 0 and 1. If we divide by 3, there are three possibilities of remainder, 0, 1 and 2. We cannot get 3. If 3 is as good as 0, basically then. So there is some problem in the division. So let us examine what will happen to each of these numbers when we divide by 10. So 10 is quite easy. The last digit of the number will be the remainder. So 78 last digit is 8, 99 and the last digit is 9. Similarly, we will find the last digit for each of these numbers. So when you divide by 5, the last digit can be 5 or 0. So we have to just see the difference between this 8 and 5, or 0 and the number. If it is greater than 5, we have to find the distance between 5 and that number. And if it is smaller than 5, we have to find between 0 and that number. Last digit only I'm talking about. Suppose let's see the numbers. So 78, last digit is 8. So 8 minus 5, 8 is greater than 5. So 8 minus 5 is 3. Similarly, 99, 9 is greater than 5. So 9 minus 5 is 4. But 3 is not, in 173, 3 is not greater than 5. So we have to do 3 minus 0. So 3 we get. So like that we do for all others. So now we will do for the last one, dividing by 2. So 2 is very easy. If it is an even, then we get remainder 0. If it is odd, we get remainder 1. So this is what we get. So next problem is, the teacher asked if 14,560 is divisible by all of 2, 4, 5, 8 and 10. Guna checked for divisibility of this number by only 2 of these numbers and declared that it was also divisible by all of them. What could the 2 numbers be? Just see these numbers. Can you find any pattern in these numbers? So what are the 2 numbers? As 2 and 4 are factors of 8, so one number is 8. So if you check by 8, you know that it is also divisible by 2 and 4. So the one of the numbers should be 8. Other one, is it 10? Because 5 is a factor of 10. Actually, the other one, because 10 is 2 into 5, but 2 is already taken in 8. So 5 is enough. So the other number is 5. So if you check divisibility by 8 and 5, that is enough. So which of the following numbers are divisible by all of 2, 4, 8 and 10? So we'll use the same divisibility test by in the previous problem. So we need to check divisibility by 5 and 8. So these 2 numbers are not divisible by 5 because last digit is 2. So right away we can say no. For these 2 numbers also, we can easily check that they are divisible by both 5 and 8. So yes. And the last number, it is divisible by 5 because last digit is 0. And 160 is divisible by 8 because 160 is 2 into 8. 20 into 8. So it is also divisible by 8. So this is also divisible by 40. Write 2 numbers whose product is 10,000. The 2 numbers should not have 0 as the units digit. So let us do prime factorization of 10,000. So 10,000 is 10 to the power 4. So 4 times if you multiply 10, you get, there are 4 zeros, right? So 10 into 10 into 10. So 10 we can write 2 into 5. So all the 10s we have split it into 2 into 5. So now if any 2 is with a 5, then the number will become 0. So all the 2s and 5 we have to separate it out. So separate the 2s and 5s. What we get is 2 to the power 4, that is 16, and 5 to the power 4, that is 625. So these are the 2 numbers whose units digit is not 0. Otherwise, all other combination will give units digit as 0. If you just take any 5 to this side or any 2 to that side, then it will become 0. One of the digits will become 0, right? So this is the only combination possible. So now that's the end of the figure it out. There are some prime puzzles at the end of this chapter. So we'll try to do a few, then remaining you can try on your own. So this is a grid. So this all these three numbers multiplied will give 75. These three numbers multiplied will give 42, and these three numbers multiplied will give 102. Then all these numbers in the columns, they will multiply and give 170. These three numbers also will give 30, and these three numbers also will give 63. So let us do prime factorization of all these numbers. So we have done prime factorization of numbers. Let us first take 75. So 75 is 3 into 5 into 5. But 5 cannot sit here because this number is not divisible by 5. So then 3 must come here. So the other two 5 we can fill in this place. So now let us take 102. So 102 is basically 2 into 3 into 17. But 17 only it can come here because this number is divisible by 17. Then 2 cannot come here in the place of 63. So 2 can come in the 30 place because 30 is the only even number. So the odd 3 will come here because 3 can go in both the places, but 2 can come only in this place because 63 is not divisible by 2. So now 42. So 2 into 7. So 7 can come here because this number, anyway, we can fill up the remaining by seeing 63 is 7 into 3 into 3, right? This part we can see and fill up the rest of the numbers. So this also will be 3 and this will be 2. So the grid is complete. Let's see the next one. So similarly, we have to do prime factorization of all these numbers. Now fill up similarly all these numbers. 105 is, we can see that this is only divisible by 7, 28. So 7 will come here. This is only divisible by 5. So 5 will come here and 3 will come here. Next, we can fill up 20 because these two are even. So 2 will come here and this is only divisible by 5. So 5 will come here. Similarly, we can fill up the rest of the numbers. This is another one. We'll quickly do it. So I'm quickly filling it up. You can refer if you want. So these two are for your homework. You can try it in your free time. So that's all for today. Please don't forget to like, share and subscribe. Thank you.